Fusion Mobile, quality e-learning experience on the go.
Hello and welcome to the class today. For our topic today, we'll be discussing angles of elevation and depression. Angles of elevation and depression. We will define what we mean by elevation and as well as depression. Alright. Angle of elevation. Let's start with angle of elevation. Okay, is defined as the angle between normal eye level. Okay, or you can say it is the angle that forms a horizontal line and the line through which an object is above. Okay, this angle, there is a horizontal line and the line through which an object is observed. Okay, is above the observer's eye. Okay, and so we'll go ahead and define the angle of depression, assuming this is the observer's eye. Okay, you're talking of the angle formed from the horizontal point of view and to the point where the observer observes an object. Okay, alright, so the angle formed between the observer's eye and the point where he observes an object. So this is the angle we are talking about, theta. Okay, so we'll as well go and we'll define angle of depression. Angles of depression. Alright. Angle of depression is defined as the angle between the horizontal eyes, between the horizontal line okay, and on the line through which the object which is below the observer's eye can be seen. Okay, so the angle of depression is given as this. You have an observer's eye, and then this forms a horizontal line, and then the observer observes something below. Okay, So the angle formed here is called the angle of depression. Alright. Okay, and then this is what we call the angle of elevation. Right away, if you look at the two angles we've had so far, you find out that they look like triangles. If you join a line from this point, this forms a triangle, and if you join a line too from this point down to the elevation angle, this forms a triangle too. So we shall be using the principles of triangles to resolve angles of this form. We shall be applying the following rules we have done so far in our classes. We shall apply the Pythagoras theorem. Okay, we shall apply the trigonometric ratios in solving triangles of this kind. Okay, and before we so that we don't forget that Pythagoras theorem states that c squared, which is the hypotenuse side squared, is the sum of the opposite side squared plus and the adjacent side squared. So without taking much of your time, we'll quickly go into examples. And then example 1, we have the following question. Right, from 2 points A and B, alright, which are 43 meters apart, and on the same horizontal line. Okay, with the foot C alright of an angle of elevation, of an electric pole. Alright, then you told the angle of elevation here of the top of the pole are 24 degrees and 37 degrees respectively, and you're told to find the height. Find the height of the pole. Alright, the first thing we'll do is to transcribe the equation into a triangle, and from there we will know how to locate the mixing sides after we've transcribed the equation into a triangle. And so the question here says that solution for question number 1. Alright, the question here says that from 2 points A and B, assuming these are 2 points A and point B, okay, 43 meters apart. The 2 points are 43 meters apart. Okay, this is the distance of separation. And then on a horizontal plane, just like we've indicated, alright, on the same horizontal line, with the foot C. That means there is a foot at this point C, and so of an electric pole, and so there is an electric pole at this point at C. Okay, this is my electric pole at C. Alright. They're on the same horizontal line. Okay, the angle of elevation of the top of the pole are this and this respectively. Okay, alright. Okay, these are the angle of elevation. Okay, they are 24 degrees and 37 degrees respectively. Okay, find the height of the pole. Find the height of the pole, and BC is equal to x, and then the height of the pole itself will be equal to h. The height of the pole will be equal to h. So if we want to find the height of the pole, we'll be using the two sides given to us to find the height of the pole. Solution, okay, we'll go this way. Alright, for us to solve this, we can say that, I know this would be a bit difficult for you to understand, but then it will help you when you meet computations that seem to be difficult this way. Okay, the sides we have, there are two triangles. If I call this side D, okay, so in triangle D B C, okay, we have that the hypotenuse side, since we have the adjacent and then the opposite side, we can say that tan theta, which is tan 37 degree, is opposite of our adjacent, which is equal to opposite there is h, and then adjacent is x. Okay, and look at the triangle very well. You find that x is equal to x is equal to or BC, can I say BC is equal to 43 minus x. Okay, fine, but that doesn't really matter. And from here we can say that tan 37 degrees is equal to hypotenuse over opposite of adjacent, so that x tan 37 degrees is equal to the height here. Alright, and in triangle ADAC, okay, we have that tan 24 degrees is equal to opposite of our adjacent. We are using the given sides to be equal to the opposite side. There is h, and then the adjacent side is 43 plus x. Okay, because you're talking about AC is equal to 43 plus x. Alright, you know, you can as well write this h as DC over BC. Okay, you can as well write this as is DC over AC. Alright, and so we have that tan 24 degrees is equal to h over 3x, sorry, 43 plus x. And so for the two heights to make sense, they have to be equal. Okay, they have to be equal. And so we have that from the last point there, you have tan 24 and 24 degrees is equal to h over 43 plus x. Okay, so that 43 plus x tan 24 will be equal to h, Okay, will be the second equation we'll have here. Okay, and the first equation stated that h is equal to x tan 37. X tan 37 is also equal to h. Okay, so since h is equal to these two values, it then means that x tan 37 is equal to 43 plus x tan 24. Okay, and so we have x tan 37 to be equal to 43 tan 24 plus x tan 24. Okay, multiplying out the brackets, and so pick x6 to one side, and so you have x tan 37 minus x tan 24 to be equal to 43 tan 24. Alright, and so when you get to this point, all you have to do is to find the values of the different tangents and then impute them on inside the simplification. And so we have tan 37 to be equal to x. You can factor this out, and this becomes tan 37 minus tan 24. Okay, to be equal to 43 tan 24, and 37 is equal to 0.753 and 6 minus tan 24, which is equal to 0.445 and 2. Okay, and so we have 43 tan 24 to be equal to 19.1448. Alright, so when you subtract the two numbers there, we have x. The two numbers there, you have 0.7536, and you subtract 452 points from it. Okay, we'll have 0.3084. Okay, to be equal to 19.1448, and therefore x itself will be equal to 19.1448 divided by 0.3084. Right? Okay, and so the final outcome we have there will be, when you divide that, you have to be equal to 62.08. Alright, so therefore x is equal to 62.08. So how do we determine the height? Remember that the first height there is h equal to x tan 37. So therefore height h is equal to x tan 37, determining the height with either of the equations. Okay, and so we have that x is equal to 62.08 and then tan 37. Alright, 62.08 tan 37. We have tan 37 to be equal to 46. Outcome is equal to 46.7790, which is equal to 47 meters. Alright, so I just omitted the tan purposely because I have to impute it directly into my calculator, and so let me try to get it back. 0.7536. okay, I think that's what we had. Fine. Okay, so the height h is equal to 47 meters. So height h is equal to 47 meters. Okay, meanwhile the base itself, x is equal to 62.08. okay, 62.08. So when you add the two sides, it will give you the total value. So here means that AC itself, AC is equal to 43 plus x, which is 62.08, is equal to that is 105.08 AC. Okay, and so you can as well use equation 2 to determine the height. Equation 2 h, where you have that h is equal to 43 plus x tan 42. H is equal to 43 plus x and then tan 42. Okay, and we had that x is 62.08. okay, tan 42. Okay, let's see whether it gives us the same thing. Alright, this one was derived using equation 1. This one we are trying to use equation 2 and see whether we'll arrive at the same answers. Alright, so at this point we have 42, and then we have 105.08 tan 42. Okay, alright, which will be equal to which will be equal to tan 42. We already know to be equal to 0. Alright, check back on our tan 42. Okay, alright, we didn't write out the figure, but then it's giving us 0.9004. Okay, when you multiply by 105.08, you have the outcome to be equal to okay, 94. That's not possible. Okay, well, let's do this. 105.08 times 1042. Alright, you have the same value. You have the same value as above. You have 47 meters. Fine. So now you can see that from both sides the outcomes are the same. From both sides the outcomes are the same. Alright, so we'll go into a different example and a simpler one so that you will understand better. Alright, so in case you didn't get the same thing, I'm sorry, this should have been 1024, not 42. There was a reverse of number there, and so you can make corrections. 1024, and this shouldn't be 0.09. we have 1024 to be equal to 1024 to be equal to 0.04452, 0.04452. alright, 0445. And so when you multiply, you have the same 47 meters. Alright, okay, don't worry, I'll make your work look neater. Let me use my eraser. Okay, 1024. Alright, okay, 0. Okay, and so we'll include 24 and its term value. Alright, this is fine. Alright, so this is 10, 24, 24, 24, and then we have 0.4452 4452. Alright, okay, so do your multiplications, you have that value there. And so taking on the next example, I was worried about the outcome, so I had to come back to resolve them. I was so worried. We'll be taking the next example. Alright, example 2 states that a man who is 1.83 meters tall, and he stands at a distance of 14.8 meters, okay, away from the base of a tower. Alright, then he discovers that the angle of elevation of the top of the tower is 63 degrees. You are told to calculate the height of the tower. And with this example, I'll be making various illustrations, and so that you will understand. A man, this is the man. Solution. Okay, if this is a man, and we are told that the man is 1.83 meters tall, okay, and he stands at a distance of 14.8 meters away from the base, okay, from the base of a tower, and this is our tower. This is our tower. Fine. Okay. And then he discovers that the angle of elevation of the top of the tower is 63 degrees. So his observation from this point, he discovers that the angle of elevation is 63 degrees, and we are told to calculate the height of the tower. This is the height of the tower. Alright. Sorry, I think there is a mix-up here. Okay, there is a little mix-up. Sorry, I think this man should come down because he makes observations with his eyes. Alright, so let's do it better. Alright, so sorry, this man should be making observation with his eyes. Okay, and then his observation starts from, and we are told he stands from a point 14 meter. Alright, this is where he stands. Okay, and then this is the tower. Alright, this is the tower away from where he stands, and then we are told that where he stands is 14.8 meters away from where the tower is, and then he makes an observation. He makes this observation. Fine. Okay, so the distinction I want to point out is that the point of interest is from this point. We here we have 63 meters, because this is the importance. The angle of elevation is the point between the horizontal plane of observation and then the plane of the point where the focal eye point lies. This is where his focal concentration lies, between here and here. That's why you have 63 degree in between, and so it means the height of the pole, the height of the man has not been included into the height of the pole. We have 1.8 meters at this point to 1.83 meters, and so we have 1.83 meters here too, and so we find the height h. Alright, look at the equations very well. You find out that we are given the two other sides, the opposites and the adjacent, and then we are not given the hypotenuse. Okay, and so how do we find h? H is opposite, and we'll have adjacent, and what works for the SOHCAHTOA is tan theta. That's the only place you have opposite and adjacent. So we have 63 degrees is equal to if I should name this A, B and C, is equal to opposite, which is AB over BC, which is equal to H over 14.8 meters. Alright, and so then 63 degrees equal to H over 14.8 meters. Alright, so that's 14.8 tan 63 degrees is equal to H. Alright, and so when you just punch that on your calculator, we have tan 63 to be equal to 14.8 times 1.9626 to be equal to H. Alright, when you multiply the two numbers, you have that H is equal to 29.0466. Okay, so therefore H is equal to 29 meters. Alright, it is H which is equal to 29 meters, but the height of the tower is equal to the man's height. Okay, the man's height plus the h we've just determined, the man's height plus h, and which is equal to man's height plus h, and the man's height is 1.83 meters, while the tower's h is equal to 29 meters. So we have 30.83 meters as the height of the tower. And supposing you are told to find the side AC, supposing you are told to find the side AC and not the height of the tower. Now remember, AC given the base of the triangle, AC given BC, AC given BC. Okay, here we have that the AC side is a hypotenuse side, and the BC side is an adjacent side. Okay, the line that works for the adjacent and the opposite is the curve section, and so you can say cos of 63 degrees is equal to adjacent, which is BC, adjacent, which is BC, over the hypotenuse, which is AC, and the BC here is given as 14.8 meters. Okay, 14.8 meters over AC, so that AC cos 63 degrees will be equal to 14.8, and then AC will be equal to 14.8 divided by cos 63 degrees. Okay, so therefore AC will be equal to 14.8. Carry out that division. 14.8 divided by cos 63, so that AC will be equal to 32.5998, okay, which is equal to 32.6 meters. Okay, so we can go and include 32.6 meters at this point. But should, in case you don't want to use the sign, the trigonometric ratios of this triangle to find the remaining part, you can as well use the Pythagoras theorem. Thanks for being part of the class. Goodbye.